right? So in that we learned what the principle of mathematical induction. So what is the principle? So if we prove by mathematical induction, so what is the first step? So first we have to take the given statement as P of n. So then the first step, that is step 1, is equal to what? Prove that P of 1 is true. So in that the first step is we have to prove that P of 1 is true. Okay. So the next step, that is step 2, is equal to what? Assume P of k is true. So in the next step we have to assume that P of k is true for some k. So the next step, so that is step 3, is equal to what? Prove that P of k plus 1 is true. So after that we have to show that P of k plus 1 is true. If all the three are satisfied, then by mathematical induction the given statement or the given result is true for all natural numbers. If all the three conditions are satisfied, hence by the principle of mathematical induction the result is true for all natural numbers. This is the principle of mathematical induction, right? So today I continue that one. I go to another problem. So using this principle you must remember the principle. Okay. So the next problem is prove by mathematical induction that 1 square plus 2 square plus 3 square plus etc. plus n square is equal to n into n plus 1 into 2n plus 1 divided by 6 for all n belongs to n. So we have to prove this by the principle of mathematical induction. Okay. So what is the first step? Let P of n. So the first step is you must consider the given statement as P of n. Okay. Let P of n is equal to what? P of n is 1 square plus 2 square plus 3 square plus etc. plus n square is equal to what? N into n plus 1 into 2n plus 1 whole divided by 6. So first you have to take the given statement as P of n. Okay. So next step 1. So what is step 1? Prove that P of 1 is true. This is our first step. We have to prove that P of 1 is true. So when n is equal to 1, P of 1 means n is equal to 1, right? So what is LHS becomes? This is our LHS, right, in P of n. So if it consists n elements, so it becomes 1 square plus 2 square plus 3 square plus etc. plus n square. n elements idaga n square tanka ide. So we consider that n is equal to 1. So 1 anaga enagutte, it becomes 1 square. One term agutte. n idaga it consists n number of terms. So when n is equal to 1, it consists only one term, that is first term. So what is the first term here? 1 square. So what is 1 square? It is nothing but 1, right? 1 square is 1. This is what our LHS. Similarly RHS becomes, so put n is equal to 1. So what will RHS becomes? n is equal to 1 means 1 into n plus 1 means 1 plus 1 into 2n plus 1. So put n is equal to 1 means 2 into 1, 2 ones are 2 plus 1. Divide by what? 6. Understand? In RHS we have n into n plus 1 into 2n plus 1 divided by 6. But in the first step we take n is equal to 1. So replace n by 1, we get this. Simplify this one. So 1 into 1 plus 1 is 2 into 2 plus 1 is 3 divided by 6, right? So multiply this one. 1 2s are 2, 2 3s are what? 6 by 6. It is nothing but 1. So therefore LHS is equal to RHS, because LHS is equal to 1. RHS is also equal to what? 1. So therefore we get LHS is equal to RHS. So hence is true, right? So step 1 is completed. Then what is step 2? Step 2 is we have to assume that it is true for some k. That is step 2. So step 2 is assume p of k is true for some k. So that is, so p of k is true means replace n by k. Okay, so it becomes what? 1 square plus 2 square plus 3 square plus etc. plus n square. But we take p of k, so it becomes k square is equal to what? K into k plus 1 into 2k plus 1 whole divided by what? 6. This is our p of k. The first step is p of 1 is true. Okay, so the second step is assume that p of k is true. Okay, so that means replace n by k. This is we have to assume. Okay, so what is the third step? Step 3. Step 3 is prove that p of k plus 1 is true. So we have to show that the step 3 is we have to prove that p of k plus 1 up to k it is true. We already assumed that. So next term yadu k admele k plus 1. So we have to show that p of k plus 1 is also true. That is, so what we have to prove? P of k plus 1 true ಇದೆ ಅಂದ್ರೆ ಏನಾಗುತ್ತೆ? k ಜೊತೆಗೆ ಇನ್ನೊಂದು ಟರ್ಮ್ ಆಡ್ ಆಗುತ್ತೆ. What is that? k plus 1. So that is it becomes 1 square plus 2 square plus 3 square plus etc. plus k square plus what? k plus 1 square. Another term k ಆದ್ಮೇಲೆ next k plus 1 ಬರ್ತಾ ಇದೆ. k square plus k plus 1 square is equal to, so k up to k andre this is the statement, right? k plus 1 andre replace k by k plus 1. So it becomes what? K becomes k plus 1 into, so observe that here we have k plus 1. So we have to replace k by k plus 1. So k plus 1 we have, so replace k by k plus 1 plus 1 remaining. So it becomes what? K plus 2, right? So k plus 2. The third term is 2k plus 1. So we have to replace k by k plus 1. Okay, plus 1. So 2 into k, 2k plus 2 ones are 2 plus 1. So it becomes 2k plus 3 plus 1 is 3. Understand? Replace k by k plus 1 and simplify, you will get 2k plus 3. So k plus 1 into k plus 2 into 2k plus 3 whole divided by what we have? 6. Understand? We have to show this. Okay. Step 3 is we have to show that p of k plus 1 is true. That is this one. We have to prove this one. So how to prove this one? So for that consider the LHS. Consider the LHS, that is 1 square plus 2 square plus 3 square plus etc. plus k square plus what? K plus 1 the whole square. This is our LHS, right? So observe that from step 2, 1 square plus 2 square plus 3 square up to k square is equal to this term, right? So 1 square plus 2 square plus 3 square up to what? K square is equal to what? K into k plus 1 into 2k plus 1 whole divided by 6. Can we replace like this? Yeah, because we already assumed that this is true for some k. So from 1 square 2 square up to k square it is equal to this one. Okay, plus remaining we have this another term, that is k plus 1 the whole square. Okay, now take LCM, that is 6 is the LCM. Write this one as it is k plus 1 into 2k plus 1. Okay, 6 into this term multiply mani. So plus 6 into what? K plus 1 the whole square. So here I take the LCM. Now simplify this one. So for that, so here also k plus 1 is a common term. Here also we have k plus 1. So take k plus 1 as a common factor. So what is the remaining? So k plus 1 removed there, we take the common factor. So the remaining is k into 2k plus 1 plus here we have 6. K have to factorize this one. So can I do it here? So here, so what are the remaining terms? We have k plus 1 into. So here we have 2k square. So k plus 6k becomes what? 7k. 6 plus 1 is 7 plus what we have? 6 whole divided by what? 6. So this is we have to factorize. So factorize 2k square plus 7k plus 6. So 2k square, 7k can be written as, so multiply 6 2s we get 12. We have to get 12, and if we add we have to get 7. So can I take 4 and 3? So 7k can be written as 4k and 3k. 4 plus 3 is 7. 4 3s are 12. Okay. So 7k can be split as 4k plus 3k plus the remaining term is 6. So here group the terms. So you are here take 2k as a common factor. Okay. So 2k common factor, the remaining is k plus here 2 2s are 4, right? 2 plus here also take 3 as a common factor, k plus 3 2s are 6. So k plus 2 and another one is k plus 2 is a common factor, right, once, and another one is 2k plus 3. So this is the factorization. You already know this one, right? So factorization of 2k square plus 7k plus 6 is equal to what? This one, k plus 2 into 2k plus 3. So k plus 1 into, so 2k square plus 7k plus 6 means what? This one, k plus 2 into what? 2k plus 3 whole divided by 6. This is our RHS, right? RHS is equal to what? K plus 1, k plus 2, 2k plus 3 whole divided by 6. We also get this. This is our RHS. So therefore, P of k plus 1 is true. Okay. So in the first step, we prove that P of 1 is true. In the second step, we assume that P of k is true. In the third step, we prove that P of k plus 1 is true. So P of k plus 1 is true. Hence, by the principle of mathematical induction, the result is true for all natural numbers. Okay. So this is the principle, right? If all the three conditions, all the three steps are satisfied, hence by the principle of mathematical induction, the given statement or the given result is true for all natural numbers. Understand? This is the method proved by mathematical induction. The continuation of more problems on this topic I will discuss in my next class.